This is Knowledge Engineering with Semantic Web Technologies. This is Lecture 2, RDF-based knowledge representation. And today, in part 7 of this second lecture of the course, we will talk about SPARQL, and we will do some more complex SPARQL queries. Okay, so let's have a look at a simple query. So what we want to do here is simply we want to select all authors with their notable works and the year of publication. So it's pretty easy. So this is all we already know. So we want to select, you see here the select clause, author, work and date. And then if you look in the work clause, we say simply author should be of type writer, so that's an author. And then we select the notable work with author, DBO notable work, work. And then we want to have the release date of the work, of course. So, and then we want to order this by date, and we limit it to the first 100. So, if you try to execute this SPARQL query, the result will possibly look like this. So what you see here in the column date, unfortunately, is not always a proper formatted date. So sometimes, as you see here, you have, for example, a URI, or you have a time span, and sometimes, of course, you also have a valid date format according to the XML schema date definition. So the problem is, it's not homogeneous. So the point is, if we want to make sense out of this column, we should filter it somehow. Okay, so let's give it a try. So what you see here is I'll try to filter this column, and I try to make a type conversion. So I convert this date to an integer, meaning somehow that I try to extract all the numbers out of it. So if there is a time span, for example, which again, for example, contains some characters that are not numbers, they will be somehow excluded by simply converting this to an integer, because then only the numbers are extracted from this expression. The nice thing, or the new thing that you see here is, from this expression, from this type conversion expression, we create a new variable. So we do a new variable assignment. We say something which is transformed here should be regarded as a new variable which has the name year. And then you see it here in the end of the query. We want to order the results in descending order according to this new variable year. So SPARQL enables you the definition of new variables, of the assignment of new variables, here among your output variables, for example. Okay, so if we try that, the result should at least somehow look better. So we try it. And as you see, it looks somehow like this. So in the lower part of the table, you already see numbers like 2014, 2013, and so on and so on. Of course, this is ordered according to the number that is extracted here in descending order. The point is, sometimes if this is a URL, or if this is a longer expression, or even a sentence, maybe several numbers occur there. And then, of course, if I do a number extraction like that, then sometimes, of course, you again have wrong results. So we must think of something more sophisticated to extract proper dates. So what could we do? Okay, we can do more complicated, more sophisticated transformations with the output variables. So besides extracting everything which is integer, we could look at the date. First, we could transfer the date to a string. And then, for example, we could exclude, of course, let's say, leading characters, only extracting or only taking into account strings that really contain a year, which is usually consists of 4 numbers. Okay, so let's have a look what we could do. So first of all, take a look at the work clause here. Here we filter all date expressions, and they should contain at least 4 characters in a row. So so they should contain something like a year. But this is not sufficient, so then look at the output variables. There I do a more complex transformation. So we have to look at this transformation, and we have to look from inside to the outside. So first what I do is I transform the date format, or whatever occurs in that column, into a string. What I do then is I do a replacement, and I do this with the help of regular expressions. So for example, I replaced everything which is not a number. So this is the regular expression you see here. So it's not, in the range of 0 to 9. This will be converted with something which is seen afterwards with nothing, so which is in empty quotes. So I convert all characters within that string expression into blanks. This is the replace command. And then from the rest, I only take, so this is of course only an assumption, I only take the first 4 numbers and I assume these first 4 numbers, they make quite a nice year. So I guess for most of the expressions this will work. So just let's have a look when we execute that query. And if you execute that query, you see in the column for year, of course you only then have 4-digit numbers here. Yeah, unfortunately they start with 6,190, so this is probably not a valid release date. But you see here, if you go down 4 or 5 rows, you see it starts with 2014, 2012, and so on and so on. So for many or for almost all cases, this works. So, of course, feel free also to experiment for yourself. Maybe you can find a better expression that really does this date extraction or year extraction in a more reliable way. Okay, so this, keep in mind, we are able to do transformations on the output variables. They can be rather sophisticated, and then we can use these transformed output variables as new variables, and we can, of course, reference them later on in our query, as we have seen here. Okay, yeah. The next point in SPARQL are so-called aggregate functions. You maybe already know aggregate functions from SQL or SQL, from relational databases. So it's quite similar here. What you can do here, for example, is not generate a list of all possible rows that somehow fit to an expression in your query. You can simply count these rows that would be in the result. So the rows in the table of the result can be counted simply with an aggregation function that is applied on an output variable. And here in the example, for example, what do we do here? We simply count how many authors are there in DBpedia. That's quite simple. So we are looking for triples in the RDF graph that consists of a subject, which is our variable author, and we say this subject must be of type DBO writer. So we are looking through the graph, and for each resulting triple, the aggregate function count increases the number by 1. And then in the end, you will get the according result. Please note that for all the examples we have here, I have in the lower right corner of the slide a link. And if you click on that link, you will get directly to the official DBpedia SPARQL endpoint, and you can carry out directly this query. So we can do that. I click on it, and this transfers us to the official DBpedia SPARQL endpoint. You see here I have the very same query, so select count of author, and of course I make a new variable out of it. So I say now this count author is a new variable which has the name num, N-U-M. And then what I do here, of course, is the regular select. I select all the authors. Okay, so let's try it out. I run the query. And the result is a table which only consists of one field, one column. The column name is then num. This is the name of our new variable that we have assigned. And you have a number. And the number is the number of triples that fit to this author pattern. And these are 27,000 and a few more. So you see there are lots of authors registered within DBpedia. Okay, so count is one of the many aggregate functions that are available in SPARQL. Okay, what else can I do besides simply counting the results? Sometimes it's interesting only to count results that differ, so to exclude redundancy. So here we have an example where we try to find out how many distinct authors are there in DBpedia who have entries for notable works. So usually, you know, of course, an author may have many notable works. So therefore, in this kind of query, there can be more than one resulting line for one author. So you have to restrict this, and you do it in the following way. So first, let's look at the where clause, what we do here. So we're looking for authors, which means variable author should be of type DBO writer. And then we say the author should have a notable work. So the property is DBO notable work, and the variable we are looking for is the work. Okay, but we are only interested in the author in the end. So what we do here is, of course, we are counting the number of authors, and to exclude duplicates, we use the keyword distinct. And with the keyword distinct that you use here within the count aggregate function, you simply then refer to distinct author names. So we can try it out again. So here we have exactly the same query. First, let's try this without the distinct keyword. So I'm deleting what we do not need. So now I simply count the number of authors who have a notable work. But keep in mind, an author might have more than one notable work. So I do the query, and you see here the result is 5,477. Okay, we assume that therefore the number of authors with notable works within DBpedia must be smaller, because there should be some which have 2 or more notable works. Okay, so let's try again. So we write here again distinct. We have to close the braces. And we run the query again. And now you only have the distinct author names. And these are only 2,832. So this is a quite lower number. So with distinct, keep in mind, you avoid redundancy and only count distinct occurrences of the variable where the counting function, where this aggregate function is applied to. Okay, so let's look further. What you also can do with aggregations like that is that you do not only count, let's say, all the authors. Maybe you are interested in, how many notable works are there per author, because we have just found out that there might be more than just one. And to do this, you can aggregate your resulting table that you have here by a variable, by the variable author, and you can, for example, order it by the author variable, and you can somehow combine all results which have the same author. And this you do by the grouping directive. So you have a group by aggregate function, which does nothing else than grouping your result by a specific variable. So what you do here, for example, is we try to find out which author wrote how many notable works according to DBpedia, of course. So we do select author, and then we say, okay, count the number of works. So we select count of works, and this row, count of works, we assign a new variable which will have the name number of works, so numWorks. And then in the work clause, we simply have, again, we are looking for authors, so author of type DBO writer, and we are looking for the notable works of these authors. And then the new thing here, the new aggregate function that you see here is the group by. So we say group by author. And the interesting thing is, okay, now all the results will be grouped by author, and for the author, one resulting line will be displayed, which means the other output variables should also be aggregations. So therefore, I count all lines which have the same author. So this is this one. And then in the end, I order the result in descending order by the number of works. This is the new variable that I have created from count works. So what will be the result of this query? We can see it here again. So you see here an ordered list of authors and the number of their notable works, and they are ordered, the author, in descending order according to the number of notable works. And we have here one with 16 notable works, which is quite a lot, or somebody with 14, or Roald Dahl, very famous author, with 13 notable works. So this is quite an interesting result. And you aggregate here, and by grouping some of the output lines together, and by applying then another aggregate function on the group of lines that are distinguished by the single variable result. Okay, so this is group by. What you can further do, you can somehow also define constraints on your group. And defining constraints on groups, you need an extra keyword, because this means first you have to do the grouping, and then for the grouping you have to define a constraint, and this will be achieved with a directive that is named having. So there you don't have a where clause. For the group you have a having clause, and this usually is only one single line, as you see here. So let's look at this at the example. What I want to do here is I want to find out which author wrote exactly 3 notable works. Of course, again, according to DBpedia. So what we do again is we have almost the same query as before, but simply after the group by clause, we have a having clause which says that here the count of works should be exactly 3. And then we order this time, of course, not by the number of works, then we order this result here by the name of the author. And if we do not state the order, then it's of course in ascending order. Okay, let's have a look. Yeah, you see here a list of authors and their notable works. So only the number of notable works, and because of the constraint that we have on the group restriction, the number of works here always is 3. So the authors are ordered in alphabetical order, ascending as you see here, and they all have written 3 notable works according to DBpedia. So this is another possibility to aggregate and to further constrain the results that you achieve with SPARQL. So as you see here, you have many aggregate functions in SPARQL available. So for example, if you have a numeric result, you also can aggregate your results by summing up all of the numbers, or by calculating the average of all the numbers of that variable, and also by determining the minimum or the maximum of the results. Another possibility would say, yeah, I simply pick one by random. Then you use the sample directive. And another interesting directive is here the group concat directive, where you can again gather all possible results that are in the group of that variable, and you can concatenate it according to some predefined pattern. So you define a specific string separator, and then you can concatenate all the various occurrences of another variable for a group aggregation. So let's have a look at an example for that one. So what do we want to do here? So we try to compare an arbitrary title of a book and non-English titles of a book. And the books should be, again, notable works by authors. So let's have first a look at the where clause here. What we do here, again, we're determining authors. So author should be of type DBO writer. Then we are looking for their notable works. Author should have a notable work. And then we are looking for titles. So first we define a variable title. So we're looking for a pattern where work has the label title. And we are looking for an alternative title, which is exactly the same pattern, which simply means work, the variable, has the label and then alternative title. But we want to be these titles different. So it means we apply a filter expression on the alternative title and say the alternative title definitely should not be the English title. So the title most probably is the English title. Sometimes when no English title exists, then it will also be a title in another language. But the alternative title should be all other titles, but not the English title. Okay, now let's look at the output variables and their aggregation. So what I want to do first is, of course, I want to have a title. So most times in the title variable, it's the English title. So I take an arbitrary one of the results here. So I say I sample the title. So I take a value of the title variable of this group that I'm just considering by random. So, and this will be then a new variable which has the name here. And then I do the group concatenation that you see here, and I do this over the alternative titles. And I say, okay, please put one after the other the alternative titles and separate them by a comma. And this again will be a new variable which will be called alt names. And of course, all this expression will be grouped by author. So for each author, I look for the titles of the notable works of this author, and I separate between titles in English and not in English, and I separate between the main title and the alternative titles. And what I do here is, for each author and for each notable work that you see here, I try to give the main title plus all the available titles in other languages, which are aggregated and concatenated in a separate field, which is separated by comma. Sounds complicated, is pretty easy. Okay, and we do this aggregation and execute the SPARQL query, and the result will be something like this. So sure, you will not read it here on the screen, but you might carry out the SPARQL query by your own. I have given you the link on the previous page in the lower right corner. And what you see here, you will get a table with two columns. The first column is name, and this is the main title of the work. So most times it's English, but as you see here, the first one is a French one, also the second one, and the third one is a Spanish one. But then the interesting thing is in the second column, in the alternative names, and for some of these works you have titles in many languages. So it's a huge field, and you see here the title of the same novel, of the same notable work in many different languages. They are simply concatenated one after the other and separated by a comma. So this is another possibility to aggregate here values from a result of a SPARQL query. So what you have learned in this lecture is how to aggregate the output of SPARQL queries and how to make more sense, how to pose more sophisticated questions. And in the next part, the officially last part of the second lecture, we will talk about SPARQL subqueries and so-called property paths.